Maybe you could turn the lights up a little bit because it's not bright enough up here. So I appreciate the people who stuck around 35 minutes after when this was supposed to start. I'm going to make this really quick just because we have 25 minutes left. And given some product launches and whatnot we've done recently, I assumed that we'd have some questions. But my name's Ian McNaughton. I'm the Senior Manager of Product and Platform Marketing for AMD Europe. A little background on me. I used to work at ATI in Toronto, Canada. I left ATI to join AMD in Austin, Texas. AMD then, a couple of years later, purchased ATI, and we've come full circle. So I've had the luxury of working in discrete graphics, and then in CPUs, and then now as AMD as a platform company. And when I was asked to come and speak to all of you, I thought, hey, you know, when I go to LAN parties, I just do Q&As. I stand on a stage with 16 boxes of T-shirts, some cute chicks, and just answer questions. So I thought, you know, what can I present on that is going to be of interest? So I decided not to present on product, because you guys probably already know what we're doing. I decided to present on how AMD is changing how we play games and how we're going to play games. Because there's a lot of cool stuff that happens in the background that you may not be aware of. So that's what today's presentation's on, and I promise to be quick. So I went to Google, and I said, in Google, I said, what is gaming? And I pressed search, and I looked at the images section, and the first 6 images that came up are these. As you can see, the all-inclusive, all-knowing, all-telling gaming platform, gaming on your handheld, playing the Wii with Grandpa, Super Mario, PC peripherals, and then some funky keyboard thing. That's gaming according to Google Images. Well, gaming according to AMD is blurring the lines of what is real and what is rendered. One of the really neat things about that is you know, I'm going to have to honestly say I have one of the best jobs in the world because I get to work with leading edge technology. I just did, thanks to Pekka and his hospitality, did 16 press briefings at the assembly for R700. So if anyone knows who R700 is, anyone? Yeah, that's pretty fast. Anyways, it's still under NDA, so I won't give you any details on it. But R700 is an example of a graphics card bringing to market that is, nothing has ever come to market that fast before. So it's really bringing the technology and the innovation to market that really blurs that line. So let's take a look at what that is. It's really about breaking the sensory barrier. So when you're playing a game, whatever that game is, whether it was Warcraft way back when or it's World of Warcraft today, you get immersed in that game. You really get immersed in what you're doing. And we want to bring technology to market that really takes it to the next step. So you can imagine a movie, which is completely passive. So you sit just like you guys are eating popcorn and you watch a movie, right? A game is all about interaction. The more interaction there is, physics or whatever that is, the more fun it is. We want to take movies and gaming and bring them together. So take the interactiveness of a game and bring it to movies and vice versa. I'm going to talk to you a little bit about a phrase we've coined called Cinema 2.0 in a bit. So to give you some examples of what 3D rendering is from a game perspective and how it's being used in movies, right behind me is a great example. We work very closely with a company called Oitoy, or Jules World Incorporated, which is the company that did Transformers, Spider-Man 3, and Superman. And when you can imagine it takes days to render a scene for a game like that, a movie like that, like Transformers. The processing power that's required is just immense. And without going into any details, Jules has been using R700 for a while now, and he has significantly cut down his render time for some of his bigger projects. So this is some examples of what is in-game or in-movie, but also can be utilized in games, right? It's really about enabling, from a technology perspective, you guys to have the movie-like experience. So from a GPU perspective, because I'm going to focus on GPUs today, we reached a turning point. We realized that the big ASIC, the big hot ASIC that got really expensive, it wasn't sustainable. So we changed the way we did things. And we said, we're going to go with a smaller ASIC, but we're going to put more of them on a board so we have more powerful, more performance, but we have cheaper cost. And with the launch of the 4000 series, you guys have, if any of you haven't yet, you would have seen the benefit of that, because we were able to bring higher performance, cheaper graphics cards to market for the first time in history. So here's a traditional GPU strategy: large monolithic die, charge a lot of money for it, and then come out with a derivative that's smaller and cheaper, and then another derivative that's smaller and cheaper. The negatives with that: power, cooling, takes a long time, whatnot. So our new, how we get to blurring the lines of what is real and what is rendered, is really scalable. And I'm going to skip through this because the last bullet's really what's important. It's about bringing you R700 or whatever the public name is going to be, and it almost slipped. Bringing the product to market at a cost that is affordable. When you look at the HD 4870 right now, it is more than affordable, available, and it's based on this strategy. So we think we have the right strategy. So let's move on. So in 1996, there was a computer. It's called ASCII Red. And ASCII Red was the world's first teraflop computer. Who knows what a teraflop is? Wow. You really don't know what a teraflop is, do you? Okay, kind of. So most people outside of Helsinki today don't know what a teraflop is. But a teraflop in 1996 was a hell of a deal. It took a computer, probably the size of all of this space, to reach 1 teraflop. It took 1,000, as it says, 1,000 Pentium, boo, by the way, processors, 500 kilowatts of power, and then another 500 kilowatts of power to cool that computer. Then you got to 1 teraflop. So to give you an example of what we brought to market, the 4850 that we just launched is 1 teraflop. So when you look at the computer 12 years ago that filled this room, we've taken that processing power and we've designed it into a graphics card. That really talks about some of the things I'm going to get into with Cinema 2.0, because that type of graphics processing performance is something that really enables the blurring of what is real and what is rendered. So pushing the boundaries of your imagination. Visual computing trends, when you look at what is really happening in movies and games. In films, as you see more and more, whether it be Iron Man or the Hulk or whatever it is, you see a lot more 3D animation in movies. So, you know, Spider-Man swinging, Superman, whatever that is. The Transformers is a great example. You could sit back and say, oh, that looks really cheesy. Or you could look back and say, wow, that looks real. What part of it's real, what part of it's not? And we're starting to be able to blend what is 3D rendered and what is real world into movies. But in the movie industry is looking at having like completely rendered movies. When you look at, you know, Shrek as an example of a cartoon, you take that to the next level of what is totally rendered without actually having actors. Complete control of emotion, complete control of everything. When you look at games, game developers are trying to do the same thing. They're trying to bring what is real world movies into games. They're trying to render what is essentially a movie into gaming. Some gamers may think that it's intrusive to the game experience. Other gamers think that it enhances the gaming experience. I don't know if there's a right answer, but there's lots of opinion there. But it still is taking, when you look at movies and you look at gaming, they're moving in the same direction. They want to take and make things more interactive. You take a movie as an example. With a rendered movie, you'd be able to actually change the outcome of what's happening. Like a game, you'll be able to make choices within that movie so that you have a different outcome. When you look at 3D interactivity, as I was talking about when you have a movie, but in gaming is the same. If you were able to take a game today and you were able to change the outcome of the game. So right now you can imagine a game, if you take the top off a game, it's like a labyrinth, right? You follow, you know, like Half-Life. You can't go this way, you can't go that way, so you have to go this way. It sort of moves you through the game. Imagine taking those barriers out. You know, World of Warcraft is a good example of taking those barriers out for the most part and allowing you to roam freely. Well, if that was a real movie-like game, you'd be able to roam freely and things would render as you were moving without limitations. And that's really where we want to get to. So in a nutshell, it's really taking gaming plus movies and it equals the image on the right. The image on the right is a picture or it's a game. Take a guess. This is Finland. I don't expect anyone to speak. Oh, you're laughing though. That's good. You must not be from Finland. It's a game. This is, I was explaining to you Oitoi, the guy who did the Transformer stuff. This is a fully rendered image of New York. And I apologize for the size. My notebook, there's no way we could run it on my notebook, or I'd show you the demo. That's a fully rendered image, which is incredible, because when you look at it from an HD perspective in like a big screen, you can't tell that it's rendered. You have no clue. The taxis look real. Everything looks real. He was questioned on the reality of it, and what he did was he took and he made the inside of a taxi blank, so that when people looked at it, when it was running the clip, they could look in the taxi and see that there's nothing inside. It was so lifelike, he was being questioned on the reality of was it a picture or was it rendered? So what are we looking to do? I'm not going to talk about this slide because it's really an it's an R700 statement. We haven't launched it yet. You know, blink twice and you're going to see it launch, so it's going to come out very soon. Some examples of what we've done, and I'll show you what we're going to be bringing to market for this round of graphics cards. You can see in 2002, with the launch of the 9700 series, we did the natural light rendering. So the one that's sitting over here, you know, we'd turn the globes and we'd have illumination. It was really neat. We thought, back in Toronto, we thought, wow, that was a cat's ass. In 2005, we did Toy Shop, which is the one over here, which was very much taking that cobblestone look that was wet with the rain. It was very, very cool. And we thought, hey, you couldn't get better than that. Then we introduced Ruby, and we introduced Ruby Whiteout, which is playing in our booth. And, you know, outside of some snow or whatnot, it looks really good. And if that was a game, that would be a pretty cool game. Well, we're going to take it one step further, and let's see how this translates. There you go. This is Cinema 2.0. This is what you're going to see based on next-generation graphics cards. It's blurring the lines of what is real and what is rendered. And I apologize for the projector and whatnot, but this is something that is realistic. This little guy here, he's not so little, but he looks like he is a piece of metal sitting on a platform. So that's some of the stuff that we're doing with the movie industry. When we talk about developers, we work with all Tier 1 developers in optimizing the games and working with the games to make sure code works and it takes full advantage of graphics performance. But here I wanted to sort of do a pseudo announcement of something, and it's really about a new partnership that ATI AMD is entering into with Blizzard. I don't know if there's many people that would argue with me here that Blizzard is by far the leading developer in the world when it comes to popularity of games. So we looked at that, and we have a very close relationship with Blizzard, and we thought, hey, there's an upcoming game that we really, well, there's two, that we really want to get involved in, and we decided we'd get involved with them. So StarCraft 2 and expansion pack for WoW are games that we're going to get involved in with Blizzard. The details you'll see it slowly trickling out as we get closer to launch of StarCraft 2. But it's an example on the developer side where we're getting involved to really bring to life more games in a more realistic way. So, like I said, I was going to keep this short, and look at that, I'm going to be almost on time. What are we doing to change the way we game? We're bringing to market a smarter engineering strategy so that you guys can go buy better, higher performance graphics cards for less money. And that may sound charitable. It's not charitable. we look to make money just like any other corporation. But what we're doing is we're doing engineering smarter so that we can actually bring products to market that are more competitive. And I think you've seen that with the 4000 series. We're driving down the cost of GPUs. We're working with our Tier 1 ISVs for a demo developer perspective. As I showcased, we're working with the movie industry to make sure that we can blur those lines further. We can learn from the movie industry and bring 3D graphics to that industry as well as leverage that into games. We just basically bring things to life. Graphics cards are designed to bring things to life. It is as simple as that. That's the easiest way I could explain it. And we're continuing to blur those lines. So to close, where do we see, the future of gaming? And I sat on CES in a panel 2 years ago, and they said, where do you see gaming in 5 years? And where do you see it eventually get to? And I said, the holodeck of the Star Trek Enterprise is what gaming should be. It should be walking into a steel room like this and just instantly being transported into something that looks a little bit like this. As I said, the New York scene with our little monster dude, This is all rendered, 100% rendered by R700s, and looks pretty damn realistic. So, any questions? You don't get to ask a question. Go ahead, ask a question. Chicken and egg, right? We as a company have increased our graphics performance by 3 times in 1 year. 3 times the performance from a year ago, as an example. It's really enabling the developers to have the performance capabilities in your boxes, because if your boxes can't run them, there's no market there, and they're not interested in doing it. So I think we're taking steps towards that. There is no end date, but I think you look at the leveraging that's happening already in Iron Man, let's say the movie, all that learning comes into games as well, because there's just a natural evolution down into games, and from a games perspective up. So there is no actual date that I could give you. I think the next 5 years are going to be just a whirlwind of innovation, because if you look at 5 years ago, Counter-Strike was probably a decent game, right? Not so much now. You look at StarCraft 1 was a 2D game. StarCraft 2 is going to be a 3D game, and that's a good example of how we're moving from a games perspective. It really depends on the lowest common denominator, and unfortunately, that's integrated graphics. So as we move that barrier up, developers are freed to develop better games. Any other questions? None? Awesome. Thanks, guys.